So we're talking about what we call the Dangote concrete road project. This is basically about 30 kilometers of road that takes you from the wharf, APAPA, right past the airport and out to OWORONSHOKI, to enable the flow of containers and freight going out of the harbour. So it's a major highway with very strategic significance. Hitech has been brought in to become involved as the, let's call it, subcontractor for Dangote to construct the road. Originally, well, there were designs that were proposed. It's either a flexible road or a concrete road. Flexible roads means it's asphalt, bitumen binder being used with aggregate. The concrete road that was proposed is the traditional, what we call plain jointed concrete, which basically means that you construct the road in slabs and then join them with dowels, with specific joints, etc. The shortcomings of the normal jointed concrete pavement has been overcome by, not so recent, but recent in Africa, continuously reinforced concrete pavement. The continuously reinforced concrete pavement is precisely what it says. It's got longitudinal continuous steel in it that keeps it together very much like a footbridge, literally keeping it together and overcoming the shortcoming or the big disadvantage of concrete is it cannot take tension. It breaks in tension first. Normally we design concrete pavements for its strength, which is compressive strength. So that the biggest problem which we have in general with roads in Nigeria, Lagos, is what I would call the lack of proper attention to drainage. The drainage provision that was provided for on this road, the old existing road, was in most cases not just inadequate, it was also a type of drainage provision that did not allow proper maintenance or was not properly maintained as such. One of the key elements which helps us to do the acceleration is in fact to have used the old asphalt layers, which are of variable thickness, and to recycle that with a Virgin recycling machine. Then we bring in good quality material called the stone base or the crushed stone crusher run material, freshly crushed hard rock, which is again spread out with a grader, etc. The cement is added. Okay, they're going to spread the cement at the specified application rate, which will mean 3% of cement mixed into 300 millimeters of the total cement treated base, passing the in situ recycler, which is going to do this recycling and mixing in. The whole process then is properly controlled in terms of density and the type of compaction, quite heavy compaction, and obviously it is allowed to gain strength, which is normally within a few days. Precisely the same sound, which shows you this is very hard, which is very good for the support of the concrete that's still going to be put on top of this. The steel is placed in very specific ways. It's got transverse reinforcement. The paver width is anything up to 9 meters at a shot. And then we've got the smaller paver that can go up to say 3.75, which is your standard. Combination of these then actually make up the full width of a 3-lane highway as we have it here. The force versus the displacement. And at some stage you'll see it break and then it will just drop away. It's starting, but it's a very slow and controlled force which is applied. You'll see in the graph there it's going up, and then at some stage you'll also see here the cracks will appear here. That's it. The concrete is mixed in a very specific, let's call it recipe. Then further of placing the concrete is actually that it is brought on site from the mixing plant or the batching plant in large trucks, which then dump it into container, which has specifically been placed next to the actual construction lane. Front end loader actually picks it up and places it on top of the reinforcement that has been placed to specification. And then the paver with a kind of an auger at the front and vibrating plates and pokers and other vibrators and smoothing plate at the back literally slides over it, vibrates it to get out all the air, to densify it, etc. Behind it follows what we call the curing compound applicator. Curing compound being sprayed on top to prevent the water from evaporating, and so that the hydration process of the concrete actually proceed with enough water in it as well. On the same machine, doing the application of the curing compound, there's also a tining machine. A tining machine is basically like a rake. It actually scratches the surface with spring steel rods that ensures that there are grooves in the pavement transversely. Now the reason for that is very pure and simple. It's to improve the skid resistance.